We've dreamed of Mars for over 100 years, a new beginning, a blank canvas, a backup Earth. It's the planet that lives in our science fiction, our billion-dollar space missions. And now, in the plans of real-world billionaires and global space agencies. We've sent rovers, we've mapped its surface in excruciating detail, we've discovered frozen water beneath the soil, and we're building the rockets that could take us there. Elon Musk says we can build a city there. NASA says we'll land humans by the 2030s. Hollywood says we'll farm potatoes in Martian soil and survive dust storms the size of continents. But here's the truth most people don't want to admit. Mars is a death trap. No air, no water, no protection from deadly radiation. It's an 80 degrees on a good day. If you stepped outside right now, you'd suffocate, freeze, and be cooked by solar radiation, all in a matter of minutes. Can we actually survive there? Not for a week, not for a flashy flag planting mission, but really survive. Can we build homes, grow food, breathe the air, drink the water, and live lives on a planet that is in almost every possible way trying to kill us? This isn't just some exotic desert. This is a frozen, irradiated wasteland 55 million kilometers from home where a single tear in your spacesuit means death and where the nearest help is 6 months away. And yet, we still want to go. So in this video, we're cutting through the fantasy. We're not here for hype. We're here for science. Can we really colonize Mars? Let's find out. So why Mars? Why this one cold, airless rock drifting out in the void has captured our imagination for generations? There are 8 planets in our solar system, dozens of moons, asteroids, ice worlds, oceans hidden beneath crusts of ice, but still we fixate on Mars, as if it's been waiting for us. It's not hard to see why. Mars is the most Earth-like planet we've found in our solar system. It has seasons, sunrises and sunsets, polar ice caps. It once had rivers and lakes, maybe even oceans. And some scientists believe it might still hold microbial life underground. It's close, at least by space standards, a few months away by rocket. And it has land, real land, a surface you can stand on, walk on. Unlike gas giants like Jupiter or Saturn, Mars has gravity, weak, yes, but enough to ground you. It's not perfect. It's barely even hospitable. But compared to everywhere else, it's possible. And that's where the fascination begins. For decades, Mars has played a starring role in science fiction. Ray Bradbury wrote about Martian settlers. Kim Stanley Robinson imagined vast terraforming projects. Hollywood gave us heroic scientists surviving impossible odds, turning Martian deserts into gardens. But now, the fiction is bleeding into fact. SpaceX has a vision for a 1-million-person city on Mars. NASA has a roadmap to put humans on the Martian surface, permanently. China, Russia, Europe, they all want a stake in the red planet. It's not just science anymore. It's strategy, legacy, ambition. Mars represents something bigger than a destination. It's a symbol of what we could become, a multiplanetary species, survivors of our own self-destruction, explorers of a new frontier. But here's the catch. Dreaming of Mars is easy. Getting there is hard. Staying there? That's something else entirely. And the truth is, most people have no idea just how brutal Mars really is. It's easy to imagine Mars as a red version of Earth. Another dusty landscape, sure, but with some clever technology and enough determination, we'll just build domes, grow plants, and start fresh. But here's the reality. Mars is not Earth 2.0. It's not even Earth 0.1. Mars is the most inhospitable place humans have ever seriously considered living. Let's start with the basics. The air. Mars has an atmosphere, but it's 100 times thinner than Earth's. And it's made up of 95% carbon dioxide. There's almost no oxygen. If you took off your helmet on Mars, you wouldn't just suffocate. The lack of pressure would make the fluids in your body boil, literally. Now let's talk temperature. The average temperature on Mars is -63 degrees Celsius. That's -81 Fahrenheit. Even in the middle of the day, at the equator, you might hit a warm -20. At night, it drops low enough to freeze the CO2 in the air into solid ice. This isn't chilly. It's deep space cold. And then there's the radiation. Earth has a magnetic field, a natural force field that protects us from the sun's deadly particles. Mars? Not anymore. Its magnetic field collapsed billions of years ago, which means that standing on the surface of Mars is like standing inside a microwave with no door. The radiation levels on Mars are 50 times higher than what we experience on Earth. Stay outside too long, and you're at serious risk of cancer, neurological damage, or worse. Even inside a habitat, without heavy shielding or underground protection, radiation will be a constant threat. Still sound like paradise? We haven't even mentioned the dust. Martian dust is made of ultrafine particles, sharp as glass. It gets everywhere, into machinery, into air filters, into lungs. Some of it is laced with perchlorates, toxic chemicals that disrupt hormones and damage human tissue. You can't breathe it, you can't grow crops in it, and you can't avoid it. It's in the wind, it's in the soil, it's in the walls. Oh, and the wind? Mars has massive dust storms that can last for weeks. They can engulf the entire planet. No sunlight, no solar power, just darkness, static electricity, and choking dust, spreading across every inch of your habitat. This is what we're up against. This is the real Mars. And yet, despite all of that, we still believe we can survive there. Not just survive, but thrive. So how exactly would we do that? Mars is a nightmare. But here's the thing about humans. We've lived in deserts, on mountaintops, under the sea, even in space. We're not easily told, you can't survive here. And that's exactly the mindset driving the science of Martian survival. Let's start with the most immediate need: shelter. You can't just throw up a tent on Mars. The radiation would kill you. The cold would freeze you. And the pressure, or lack of it, would make your lungs collapse. So scientists are working on pressurized habitats. Think, inflatable modules with rigid shells, built from materials like Kevlar and polyethylene. Others are proposing habitats buried under Martian soil or built inside ancient lava tubes left behind by volcanic activity. Underground, you're protected from radiation, temperature swings, and meteor strikes. Next, oxygen. You can't ship breathable air to Mars, not in the quantities needed for a long-term colony, so we have to make it there. NASA has already tested a prototype called MOXIE, an experiment that pulls carbon dioxide from the Martian atmosphere and converts it into oxygen through electrolysis. It works. It's small for now, but scaled up, that's breathable air made right on Mars. Now, water. Mars looks dry, but beneath its surface, especially near the poles, there's ice, lots of it. And in some places, it's just centimeters below the ground. Future colonists could mine that ice, melt it, purify it, and use it for drinking, growing food, even making rocket fuel by splitting water into hydrogen and oxygen. Which brings us to the next challenge: food. There's no Martian Whole Foods. You're going to need to grow everything you eat. But Martian soil isn't exactly farm-ready. It's toxic, low in nutrients, and barely retains moisture. So researchers are working on closed-loop hydroponic systems, growing plants without soil, using nutrient-rich water and artificial light. Algae is another candidate: high protein, fast-growing, and perfect for recycling waste. Not gourmet, but it could keep you alive. There's also a growing interest in insect farming: crickets, mealworms, packed with protein, and far more efficient than traditional livestock. And then there's power. Solar panels work on Mars, but only when it's not covered in dust, which is a problem since Mars loves to throw planet-wide dust tantrums. That's why many experts are pushing for nuclear power: small modular fission reactors that can provide consistent energy day and night, storm or shine. And finally, waste. Every breath, every crop, every flush, it all has to be recycled. Permanently. Closed-loop life support systems will need to purify water, scrub carbon dioxide, and reclaim every possible resource. It's not just survival, it's sustainability. And it has to work perfectly. Because on Mars, there's no backup plan, no quick escape, no resupply drop from Earth. Everything, your air, water, food, energy, safety, has to come from Mars itself. And somehow, it's all starting to look possible. Piece by piece, the science is falling into place. But just surviving on Mars is only half the challenge. Getting there, that's another beast entirely. Let's say we solve the problems on Mars. We figure out how to build habitats, make oxygen, grow food. Let's say the science all lines up. There's still one enormous problem standing in the way: getting there. Because the journey to Mars is not a road trip. It's not even like going to the moon. It is one of the most extreme, dangerous, and unforgiving voyages humanity has ever attempted. First, distance. Mars isn't next door. It's an average of 225 million kilometers away. Depending on the alignment of the planets, a one-way trip takes 6 to 9 months, longer if you miss the launch window. That's half a year in a tin can floating through deep space. No pit stops, no resupply, no rescue. Now imagine living in that cramped spacecraft with no gravity. Microgravity might look fun in astronaut videos, but long-term, it wrecks the human body. Your muscles weaken, your bones deteriorate, your vision can change permanently, your heart literally shrinks. Astronauts on the International Space Station train obsessively and follow strict routines just to maintain their health. And they're only 400 kilometers from home. Mars is 550,000 times farther away. Then there's the psychological toll. 6 months in isolation, in close quarters, with no privacy, no fresh air, no escape. You're millions of kilometers from Earth, with no live communication. Just a time delay of up to 22 minutes each way. No FaceTime, no real-time help, no reassuring voice when something goes wrong. This isn't like being far from home. This is being alone in the void, with a one-way ticket and no guarantee of return. And if something breaks, there's no spare part delivery, no rescue shuttle. If your life support fails, or someone gets seriously injured, there's one outcome: you don't make it. That's not science fiction. That's the cost of a Mars mission. And remember, this is before you even land. So before we look forward to the cities and civilizations people dream of building, we need to ask something else. Should we even try? We've talked about how we might survive on Mars, but now we need to ask something harder. History is filled with examples of colonization that began with grand ideals and ended in exploitation, inequality, and destruction. So, who owns Mars? Right now, legally, no one does. The Outer Space Treaty, signed by over 100 countries, says no nation can claim another celestial body. But treaties can be ignored, laws can be rewritten, and once there are lives and livelihoods on the line, ideals can fade fast. We could send people to Mars within 2 decades. Mars offers humanity a challenge. It shows us what we're capable of, but it also forces us to ask, who do we want to be when we get there? Because going to Mars won't change us. Only we can do that. So, can we colonize Mars? The answer, as you've seen, isn't simple. Technically, yes. We're building the rockets, designing the habitats, solving problems that once seemed impossible. Piece by piece, mission by mission, we're pushing the limits of what humans can do. But the real question isn't just can we, it's should we? And if we do, what kind of future are we building? Because Mars isn't just a planet, it's a test. A test of our technology, a test of our ethics, a test of who we are when no one's watching. If we go carrying all the things that make us human: the brilliance, the ambition, the creativity, and the flaws, the inequality, the conflict, the short-sightedness. We have to choose what we bring with us and what we leave behind. Are we ready to become a multi-planet species? Not just technologically, but philosophically, culturally, responsibly. Because the story of Mars won't be written by rockets or robots, it will be written by us. So, can we really colonize Mars? Science says, maybe. But the rest, that's up to you.